This is a video for 5.3, problem number 75. In this problem, it says there's a little icon here. It says that you can use a calculator. So that's the first thing, is you want to use a calculator and you want to graph this function on your graphing calculator. I did it here on Desmos because it's easier for me to do in this program. But graph it on your graphing calculator and get an appropriate window. So I actually did part C first. And I made it so I could see this really well, so I could see what's going on really far here to the right and really far here to the left. And I made it not so high and low here, so it spread it out so I could see that this is, going up and down and all that stuff. So let's go to problem A. Part A, it says, is it even or odd or neither? Well, what we notice is that this picture, if you were to spin it 180 degrees, it would just land right on top of itself. So it has 180-degree rotation, and that is one of the definitions of an odd function. So it's an odd function. The next part is part B, and it says find the x-intercepts. And if you look at these, they happen, and there are infinitely many of them. The x-intercepts actually just touch the x-axis. Infinitely many. There's on this side and this side, and they look to be equidistant. So you set the equation equal to 0, and you solve, and you find, oh, it's at 2 pi and 4 pi, and every time you put in a 2 pi, this the cosine becomes 1, so you have 1 minus 1, and then this becomes 0. You can't plug in 0 because you would be dividing by 0. So we want to say all the even pi's, both positive and negative, even pi's, but not 0. So I say it's any 2 pi where the n can never be 0, so you don't have a x equal to 0. We did part C already. We graphed it. So we've got that. Part D says describe the I can't read it. I got it really small here. Oh, describe the behavior of the function as. Oops, sorry about that. As the function goes really. This part here means as the function goes really far to the left or really far to the right. So that was one of the reasons to graph this properly, that I looked real far here to the right and real far here to the left, and you're noticing it's flattening out. And so as x is approaching either positive or negative infinity, the function is approaching 0. The last part of this is to talk about what I mentioned up here about how you can't ever have x equal to 0 because you would be dividing by 0. And so x cannot equal 0 because you can't divide by 0. But as the function gets closer and closer to 0, it's not the function, as the x values get closer and closer. So I have here, as x approaches 0, the function approaches 0 also. It just never can equal 0.